This lesson is for 8.2. So if you have not already done your Spark, if you will go ahead and try that first and then come back and see a way that I thought about it. So today we are going to be working on writing and evaluating numerical expressions when we use the order of operations. So we're going to write them out like a problem. This word evaluate means that we're going to solve. It's just another word for solve. And we'll talk about what a numerical expression is. So an expression just means it does not have an equal sign. And we have to follow those same mathematical rules when we are doing math problems. So for the Spark here, we have 2 tour groups are visiting an aquarium. There are 20 children in one group, 22 children in the other. Along with the 2 group leaders, there are 5 additional adults between the 2 groups. If the cost per child is $9 and the total for both groups is $490, what is the cost per adult? So that was a lot of numbers and a lot of information. So I'm going to start and I'm just going to write out and read this problem piece by piece to see what do I know. So there are 20 children in one group and 22 in the other. So I've got group 1 here and I've got group 2 here. So I've got 20 children and 22 children here, along with the 2 group leaders. So we've got 1 adult for the group leader. So 1 adult group leader, 1 adult group leader. So there's 2 adult group leaders. There are 5 more adults between the 2 groups. So that word between is very important. There's not 5 in each group. There's 5 all together. So we've got 1, 2, 3, 4, 5 more adults that are sharing the groups. The cost for all the children, for each child, per child, for each child is $9. So each of these I'm going to times by 9, and each of these we need to times by 9. And then the whole entire total needs to equal $490. And I'm looking for the cost of 1 adult. So first we need to see how much was spent on the children. So 20 times 9, so each of the children costs $9. So there's 0 and 18. So these children were $180. And then these children in this group were 2 times 9 is 18. 9 times 2 is 18 plus 1 is 19. So the kids in this group cost $198. So altogether, the children cost $180 plus $198. So there is 17 and $378. So together, all of the kids cost $378. So all the leftover is for the adults. So let's take this away and see how much all of the adults cost. So we need to borrow here is 8, and we borrowed a whole group. There's 2, 1, and 1. So all of the adults together are $112. So this is the kids, this is the adults, and all together is $490. But the question asks, what is the cost for 1 adult? So I need to come see how many adults I have. 1, 2, 3, 4, 5, 6, 7 adults. So we're going to take 112 and divide it by 7 to see how much 1 adult will be. So it can't go into 1, but it goes into 11 one time. 11 minus 7 is 4. Bring down the 2, 7 goes into 42, 16 times. So every adult costs $16. So breaking up your problems step by step, making lists of what you know is going to help you. So we could set up that problem another way. So we could say that we have 20 children and we have 22, so we can write it out mathematically as well. And we wanted to add those together. And that's the first thing we did. And then we took all of those kids and we multiplied that by 9. So remember, when we have these problems here in the parentheses and we want to multiply, you can just stick it right outside the parentheses in front of it. And that tells us that we need to multiply. So we added all the kids together, times by 9 gave us 378. So we need to do all of this first, and then we took 490 and subtracted from that. And then, so now we've got to do this all first. This is kind of a step-by-step problem. And then we could divide by the 7 adults. So when you're working with parentheses and brackets, you always start at the innermost parentheses. So here's the inside ones that tell us 20 plus 22. And we times that by 9 to get 378. Now we come to our next parentheses, which is 490 minus 378, which is 112. And we're taking all of this and dividing it by 7. We have to use these parentheses and brackets because we wanted to add first. Then we wanted to multiply. Then we wanted to subtract here. So you've got to go step by step and think about where your parentheses need to go to tell you what to do. So lots of ways to come up with the same answer there. So a word we need to talk about is a numerical expression. So in here, you can hear almost the word number. So numerical just is another word for it's made up of only numbers. And an expression is something that does not have an equal sign, no equal sign. It's just the problem. No answer, no equal sign. So a numerical expression will only have numbers and operations, no equal sign, no variables. So here are a couple examples of numerical expressions. 7 plus 8 times 2 squared. All of these are numbers and operations. Here's another example, 25 minus 16 plus 9. Only numbers and operations. So let's take a closer look at these numerical expressions. So every time we have an expression and you have parts of it that are added or subtracted, so this only is true when we are adding or subtracting, we call each of those parts a term. So this problem here, we have 16 plus 7. It's an expression, a numerical expression, only numbers and operations, and I can see that it was added. So on either side of the add sign, here's one term, here's another term. So these are called terms. So we have 2 total terms, 1, 2, and they are added together. So these terms are going to help us look for parts of the problem that we need to work with. So let's look at a few more examples here. So we want to know how many terms do they have and what did they do with the terms. So remember, terms, we're looking for adding and subtracting signs. Multiply and divide are not terms, they are factors. So that is and quotients, so that is something different there. So adding and subtracting, so I can see I've got 1 here and 1 here. So every other part of these things are terms. So here we have 1, 2, three terms. So this has three terms. And the first ones were added together. So the terms, we have 8, 5, and 4. The first two were added together. The next two were subtracted. So what are the terms? How did they get there? 3 total. Here they are. How did we get there? So let's go ahead and try this one. So write down how many terms, and then what are the terms and how did they get those? So I can see my plus sign here. So I like to circle those so I can see each side of them. So the terms, we have 2 total. They are 9 and 5. And to get those 2 terms, they were added together. Okay, let's try a trickier one here. So go ahead and write this problem down. So 6 plus 7 times 4. Then we want to go and circle any of the adding and subtracting operations. So everything on this side is 1 term, and everything on this side is 1 term. So we can see here, every time, if I have 1 add or subtract sign, that means I have 1 more term, 1, 2. I had 1 add or subtract sign, so I had 2 terms. When I have 2 add or subtract signs, then we had 3 terms. So we've always got 1 more term than we have add or subtract operations. So here I have the term of, so I have 2 terms, so 2 terms. This first term is a 6, and the second term is 7 times 4. So these are not terms individually because they're not added or subtracted. So if you remember, when we have 7 and 4, those are actually factors. 7 times 4 is 28, and 28 has factors of 7 and 4. So together they make a term. Separately, they are factors. So 2 terms, the term is 6, and 7 times 4 is a term. So 1 term is 7 times 4, but then separately, 7 times 4 are factors. So let's try one more of those. So we have 3/4 minus 2/3. So go ahead and circle any add or subtract operations that you see. So I can see here that we have a minus sign, a subtract symbol. So that means I have 1 term here and 1 term here. So together we have 2 terms. I have a term of 3/4. I have a term of 2/3. So those are the 2 terms here. Now, when I break each term up, this one is going to give me a quotient. So even though it's a fraction, yes, 3/4 is a fraction. 3 divided by 4 is 0.75. That's a quotient. So this is 1 term that is a quotient. And this is 1 term that is a quotient. So when I do 2 divided by 3 and get 0.666 forever, that is the answer to a division problem. So when we multiply, they're called factors. When we have fractions, this is really just a divide symbol, and we call it quotients. So circle your add or subtract signs. Everything between those is a term, and then you can tell me were the terms added, were there factors, were there quotients. So I want you to go ahead and try task 1 here. So task 1, just went over those same vocabulary words that we did, so those numerical expressions, and then you are going to go through and read the expression. If you need to write it down and circle how many add or subtract signs it has, look for the parts. So if we did this first one together, we would circle the plus sign, look for the parts on either side, tell me what they are, how did they get there. So you go ahead and go through each of those. Part C has first think about this expression, and then just think about the part of it 4 times 5 and select all that are true. So go ahead and try out task 1 and come back when you are ready to do task 2. So task 2 is going to ask us to write a numerical expression to represent the phrase. So we have here the product. So product means the answer to a multiplication problem. So the product of 5, so here's our first number, and the sum of 3 and 6. So this one is telling us that we want to add 3 and 6 first. We want the sum of 3 and 6 to multiply by 5. So go ahead and see if you can write out the expression for this problem and then come back and check with me. So go ahead and pause the video and do that. So I know I want the sum of 3 and 6 first. So I need to add these together. And since I want to do them first, we need parentheses on those. And then we're going to times that by 5. And if you remember, when I am giving the 5 to the 3 and the 6 together, I can just stick it out in front of that group. And when there's no symbol, it means to multiply. So let's look at a very similar problem that has the same numbers, very similar words, and how it might be different. So this one just says the product of 5 and 3 plus 6. So go ahead and see if you can write that one out and see how is it different from the one above. So this one is telling me to do the product of 5 and 3. So that one just means 5 times 3 plus 6. So we can see a big difference here is that word sum. When we have that word sum in there, it means it wants us to find a total of our adding first. If it just says to plus 6, then we're just doing that after the fact. So on this problem, we would do 5 times 3 first, which is 15, and then add 6. Up here, we would do 3 plus 6 first, which is the sum of 9, and then multiply by 5. So you've got to pay attention to those little key words that tell you, are you making a total here? Or are you just adding on 6 more? So let's look at one more here. So this one says to do the difference of 7 and 4. So go ahead and see if you can write an expression for the difference of 7 and 4. So difference means to subtract. 7 minus 4 is 3 if we were solving that. So let's look at a very similar problem here. So this one says the difference of the square of 7 and 4. The difference of the square of 7 and 4. So if you remember, square means that we are going to put the exponent 2, because once you found it one way, you would just make it perfectly the other, and it would make a square, an array square. So the difference of the square of 7 and 4. So I still need that difference of 7 and 4. So 7 and 4. And if we want to do that first, we need to put parentheses around it. And then we'll find the square of that. So if we were doing this one, so this one ended up equaling 3. So 7 minus 4 is 3. But then if we square it, 3 times 3 equals 9. So 9 makes a perfect square. 3 this way ends up with a perfect square with 9 in it. So the difference of the square of 7 and 4. So we had to subtract first, put those parentheses, then add our square outside of that. So go ahead and try task 2 here. So task 2 is going to tell us to think about this product of 7 and the sum of 5 and 4. So select all that are true there. Select an expression that matches the difference of 9 and 3. and then select the difference, the square of the difference of 9 and 3. So go ahead and try each of those and come back when you are ready to do task 3. So task 3 is going to talk about those order of operations steps here. So I like to call it gems to help me remember. I do my groups first, which is my parentheses or brackets. I do my exponents next. And remember from yesterday that exponents do not mean, if I have 3 times 2, that does not mean 3 times 2. That means 3 2 times. And then we multiply and divide. So our multiplication operations, the opposite of multiply is divide. We do it like we read. And then our subtraction ones, the opposite of subtract is to add. And we do those also like we read from left to right. So remember this word evaluate. It just means to find the value. It's another word for solve what you are able to. So task 3, we're going to use our steps here, our order of operation to evaluate, solve, and on each step, we want to identify what did we do. So this one here, we do not have any parentheses, so no groups or parentheses. So exponents comes next. So we do have an exponent here. So we need to do, I always like to write it out so I make sure I get all of them. 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. So I'm done with this. So it equaled 8, and I bring everything else down. So here's my new problem, and I said that I just did the exponents. So we don't have any more exponents. So now we're looking for multiply and divide. So no, yes. So we need to do 5 times 3 is 15. Bring everything else down. We had to multiply to get this answer here, this part of the expression. Now the only thing left to do is do 8 plus 15 is 23. We had to add those. So each step, you just go, do the next part. How did I get there? Do the next part. How did I get there? So let's go ahead and have you write this one down with me. So 64 divided by parentheses, 19 minus 11, close parentheses, plus 4 times 2 cubed. Let's go ahead and get that written down. And then look and see, what do you think we need to do first here? So our G stands for groups. We are looking for anything in parentheses or brackets here. So if we do this first one, 19 minus 11 equals 8. So I bring that down, and then here's my divide and my 64 plus 4 times 2 cubed. We did the parentheses. So I have no more parentheses. So now I'm looking for any exponents, which we have one here at the end, 2 times 2 times 2. So go ahead and see if you can do 2 cubed and bring it down and see what the next step of the problem looks like. So that next step looks like, so 2 cubed is 8. So I bring everything else down, and I just did the exponents. So now we have no more exponents. So we're looking for multiply and divide left to right. So coming here is our first one. So go ahead and do that part of the problem and label what did you do. So 64 times divided by 8 is 8 plus 4 times 8. And we had to divide. So we're still looking for any multiply and divide. Looks like we have another one here. So go ahead and do that next part of the problem and label what operation we did. So 4 times 8 is 32. We bring everything else down, and we had to multiply. And then finally, 8 plus 32 is 40, and we had to add. So let's try one more of these before I have you go on to task 3 to do some on your own. So again, we want to write down our problem and follow our order of operation steps. So we have 4 plus 19 minus 7 plus parentheses 6 plus 2 close parentheses squared. So the first thing we're looking for is our groups. Let's go ahead and do anything in the parentheses and bring everything else down. So 6 plus 2 is 8. We still need to square that. Bring every part of the other parts down. So we just completed the parentheses. So we have no more parentheses. So now we're looking for exponents. We have one here. So remember, this is not 8 times 2. This is 8 times 8. The base is 8. We want that 2 times. Let's go ahead and complete that next part and write down the new expression. So this 8 times 8 is 64. We bring everything else down. We just completed the exponents. We have no more exponents, so now we're going to move on to our multiplication operations. So we're looking for multiplying and dividing. Doesn't look like we have any here. So now we're looking for our subtraction operations. The opposite of that is to add. We do it like we read. So we do this first part here. So go ahead and do that. Bring down everything else. So 4 plus 19 is 23. Minus 7 plus 64. I had to add to do that. So we're just have all add and subtract. So we're just going left to right. So 23 minus 7 is 16 plus 64. And we subtracted those. And then finally we have 16 plus 64 is 80. And we had to add those. So go ahead and work on task 3 here. So it's going to give you, it's going to break it down step by step, and you need to decide what was the step that they did to get from here to here. So go through what would I do next? That goes here. What would I do next? That goes here. Same thing. So it told us this first one, they did the parentheses. Here's my new expression. To get to 9, they did the parentheses. So now I'm going to look at this part. What would I do next? What did I do? So it kind of goes kitty corner to put what did I do? Put it down. And then go ahead and answer all of those. And when you're ready to move on to our last task today, go ahead and flip over to task 4. So task 4 has a cute little puppy here, and it says that a staff member is buying beds for all of the dogs in a shelter. There are 10 dogs in one building and 14 dogs in another building. The price of the bed is shown here. So first, we need to write an expression. Remember, that's just the problem to represent what you would do. So I want you to go ahead and think about, you've got 10 dogs and 14 dogs, and I want to buy beds, $12 beds for all of them. What problem could I do? And there's more than one way to write this out. So if I were doing this problem, I would add all my dogs together first. And I would say, here's all of my dogs. Whoops, 14, not 12. Here's all of the dogs. And I want to buy each of them $12 beds. So now it wants to know how many terms are in this expression. So I can see we have 12 and parentheses 10 plus 14. I only have one adding and subtracting sign. So I have 1, 2 terms in this. So now we're going to go ahead and solve this. So we have $12 beds, 10 dogs plus 14 dogs. So we want to do the parentheses first and then multiply by 12. So go ahead and do that to get that answer. And then I want to look at one other way to solve that. So go ahead and do that first. Okay, so you should have completed this. Another way we can solve this problem is to use the distributive property. So when we are multiplying two terms in parentheses, you can try this. So here's our problem. Here's my two terms, 10 and 14. And I'm going to multiply the 12. I'm going to give the 12 to each of them. Giving the 12 to the 10, giving the 12 to the 14. Because we could do two separate problems here. We could have found how much the first building dog beds cost. We could have found how much the second building dog beds cost. And then we could have added them together. So this distributive property is just showing us what we could do here. So if we did 12 times 10 and 12 times 14, we would want to add those together. Give, give. So this only works when you have terms inside your parentheses and you're multiplying. So we would do each part. So I would have to multiply first. So 12 times 10 is 120. 12 times 14 is 166. We're adding those together now is 288. So this should match up with your previous answer. So again, lots of ways to do the same problem. So I like to write it out this way because I think it's shorter than writing it out this way. But this way is sometimes an easier way to do it mentally. So 10 plus 14 is 24, and I don't know 24 times 12 off the top of my head. But I could figure out 12 times 10 and 12 times 14 in my head, and then I added those together. So using that distributive property can help break things up into simpler pieces sometimes. Okay, so go ahead and complete task 4 here. So task 4 just goes over that same problem here. So what expression would we use? I was checking all my answers first to make sure I knew what I was doing. And step by step, how would we break that up? And then could you use that distributive property there? So if you have any questions on this lesson here, please be sure to let me know and we can set up a time to meet together. Okay, go ahead and complete your tasks for the day and get your check for understanding done.